Okay, so we're going to go right ahead and balance some more equations, and I get some tips. I call them tips de marquis. Some tips to help you to balance the equations. Now, obviously, there are some exceptions. Sometimes we have those in chemistry, but here's some tips. When you're balancing equations, I always like to start with the cation. Part of the reason is because the cations, there are so few polyatomic cations that it makes sense to start with a cation. So I always start with a cation. I look on the reactant side, look on the product side, see how many there are, and adjust if I need to adjust. When I say adjust, I mean put some coefficients in. If the cation is a polyatomic, then I tread gently, tread lightly. Another thing I do is if I change one that was already balanced, that was an example of like my hydrogen reacting with oxygen producing water. I initially looked at hydrogen, it was okay because I had 2 on the reactant, 2 on the product. I changed my O's, and so that changed my H's on the product side. I needed to come back and fix it right away. So again, if I change one that was already balanced, I fix it right away. It usually will help everything out in the wash later. I also avoid polyatomic ions and their atoms until later. So something like if it says sulfate, I would do that S and the O a little bit later on as I go through the process. And I usually do the ones that occur in more than one reactant or product last. That happens a lot of times with oxygen because it's in a couple of different polyatomic ions. You might see oxygen in every reactant or product in the entire equation. So I would usually do oxygen last. 9 times out of 10, it ends up being completely cleaned up as you go through the other ones. So that's basically my tips. Start with the cation. If I change one that was already balanced, I fix it right away. Avoid polyatomic ions and their atoms till later, and do the ones that occur in more than one reactant or product last. Let's take a look at an example, and I think that might help you out. So here we are. Aluminum sulfate reacts with sodium phosphate to produce sodium sulfate and aluminum phosphate. Okay, first step is taking that word equation and writing a formula equation. Again, I don't know how comfortable everybody is with that. You probably feel the need to say, okay, aluminum, I look it up on the periodic table, is a 3+ charge. Sulfate is a 2- charge. So again, you got the 3+, the 2-, Al2SO4 3. Hope everyone was able to see how I did that kind of. We got a 3+, 2-. Our least common is 6. So I need 2 aluminums and I need 3 sulfates. Okay? Reacts with sodium. Sodium's a 1+, it's in the alkali metals. Phosphate, it's another one of those polyatomics. So I've got my 3+, my 1+ and my 3-. I need 3 sodiums to balance off that 3- charge on the phosphate. So Na3PO4 reacts with them to produce sodium sulfate. Well, notice my sodium. Let me go ahead and grab a different color here real quick. Let me grab this black one. Sodium is now with the sulfate. Sodium is still a 1+. Sulfate is still a 2-. So my formula when they get together would be Na2SO4. I don't look on my reactant side and worry about the fact that I have 3 sulfates. The reason I have 3 sulfates over here is because when sulfate is with aluminum, I need 3 to balance the charges with a 6+, 6-. I don't worry about the fact that I have 2 sodiums, yet over on this side I have 3. The reason I have 3 is because when sodium is with phosphate, I need 3. But when sodium is with sulfate, I only need 2. So we don't worry about that. We write the correct formula for the compound and then worry about balancing it with coefficients after. And aluminum phosphate. So there's one product, and my other product would be aluminum phosphate. Well, aluminum, when it gets together, which is a 3+, with phosphate, which is a 3-, that's a 3+, 3-. You only need one of each. So aluminum phosphate, AlPO4. So now I've written my correct formulas for my formula equation for my word equation. Now I need to check to see if it's balanced. Let me go ahead and grab this white one again here and say, all right, let's look at our reactants and products. my tips, and I got this written all over the place, so let me go ahead and show me my tips. I would ignore oxygen until the end. Notice that oxygen is in every single one of these. So I would ignore oxygen till the end. That's one of my tips. I'm also going to ignore my polyatomic, or avoid them until a little bit later. So the S and the O, the P and the O, I'm going to wait for a little bit later. And again, we do each of them individually. Don't try to do the sulfate all together or the phosphate all together. But I'm going to do each one of those atoms a little later. And then so I guess I'm going to worry about this changing later on, but let's take a look at the first thing. So I'm going to do my cations first. I have 2 aluminums, and over here I have 1. So coefficient in front of my aluminum phosphate. That 2 now distributes to the aluminum. I have 2 aluminums on both sides. I'm good. Let's now go to my sodiums. I have 3 on the reactant side and 2 on the product side. We find least common multiple when you put coefficient in front. Just in math, coefficients multiply. So if I have 3 on this side and 2 on this side, I would need 2 and 3 respectively to give me my 6. So now I have 6 sodiums on either side. Okay. Now I'm going to go to my sulfurs, I guess. All right. I have 3 sulfurs on the reactant side, knowing that that coefficient, that subscript 3 gets distributed to both. So 3 sulfurs, and this coefficient gets distributed to both. So I have 3 sulfurs. I'm all set with my sulfurs. And now I'll do my phosphoruses. Notice again, I'm saving oxygen till last. I have 2 phosphoruses here. That 2 coefficient distributes to the phosphorus. I have 2. And I have 2 phosphoruses here. I'm okay. And lastly, let me clean this little distribution arrows out, because I'm going to do my oxygens. And my oxygens I do last. I have 12 O's here. I have another 8 O's, so I have 20 O's on this side, and I have 12 O's and 8 O's, which is 12 total. So notice the oxygens are balanced, and so now this is my perfectly balanced equation. A little ode to Mr. Dumas, my chemistry teacher. Balance an equation. So there you are. I would need 1 aluminum sulfate, 2 sodium phosphates, 2 sodium sulfates, and 2 aluminum phosphates to balance this equation.